If you thought the latest images from the James Webb Space Telescope were impressive, what you're about to hear will completely change your perspective. A new space telescope has quietly begun sending back images so detailed, so vast, and so revealing that scientists admit they were not prepared for what they're seeing. The Euclid Space Telescope has released its first light images, and they don't just show galaxies. They reveal structure. They reveal hidden patterns. They reveal a universe that feels far more complex than we expected. Tonight, we're going to walk through what Euclid has captured and why these images are being called revolutionary. Because once you understand what you're looking at, they become something else entirely. Something unsettling. Euclid is not a normal telescope. It was never designed to zoom into a single nebula or focus on one galaxy. Its mission is far more ambitious. Positioned about 1.5 million kilometers away at Lagrange Point 2, it observes the universe on the largest scale ever attempted. Its ultra-wide field allows it to capture enormous portions of the sky in a single observation while still maintaining extraordinary resolution. Millions of galaxies. All in one frame. But what makes this truly different is that Euclid is not just mapping light. It is mapping the influence of dark matter using gravitational lensing. Tiny distortions in galaxy shapes caused by invisible mass bending space. In simple terms, Euclid is revealing the hidden skeleton of the universe. When Euclid sent back its first mosaic of the southern sky, scientists were stunned. In a short observing window, it captured hundreds of images covering an area hundreds of times larger than the full moon. Stitched together, they revealed millions of stars and galaxies. And that is only about 1% of what Euclid will eventually map. What you're seeing is not the full picture. It is just a fragment of something incomprehensibly larger. Researchers can zoom from gigantic cosmic structures down to individual galaxies without losing clarity. This isn't just a photograph. It is the beginning of the largest and most detailed 3D map of the universe ever created. And almost immediately, it began raising uncomfortable questions. One of the biggest shocks came from the Perseus cluster, about 240 million light-years away. In a single image, Euclid captured over 1,000 known galaxies. And more than 100,000 distant background galaxies. But then came the surprise. Hundreds of previously unknown dwarf galaxies hidden inside the cluster. Entire galaxies that had escaped detection until now. That matters because dwarf galaxies trace dark matter. Their positions reveal where invisible mass is concentrated. And what Euclid suggests is unsettling. The universe may not simply contain dark matter. It may be built around it. Euclid also revealed chaos at smaller scales. In galaxies like NGC 6822, it detected ancient stars with very low metallicity. Stars that resemble conditions from the early universe. In dense star clusters like NGC 6397, it resolved faint stars lost in glare for decades. And in regions like the Horsehead Nebula, it hinted that rogue planets drifting without stars may be far more common than we imagined. These images do not show a calm universe. They show a crowded, restless cosmos shaped by both visible and invisible forces. But then astronomers began connecting more of Euclid's data. And that's when something even more striking appeared. Galaxies are not randomly scattered. They lie along enormous filaments stretching across hundreds of millions of light-years, intersecting in dense nodes where clusters form. This is the cosmic web. And Euclid makes it look almost like a giant neural network spanning the universe. Matter flowing along invisible pathways shaped almost entirely by dark matter. The unsettling part is not just that these filaments exist. It is their scale. Everything we see is inside this structure. Every galaxy. Every cluster. Every vast void. All guided by forces we still cannot directly detect. Euclid's precision in gravitational lensing makes that even more powerful. By detecting tiny distortions in distant galaxies, it reveals massive dark structures bending space itself. Structures that emit no light, reflect none, yet outweigh everything we can see. Euclid is showing us a universe where the dominant form of matter is something unknown. Something silently controlling the motion and fate of galaxies. Then Euclid reached deep time. Some galaxies in its images are over 10 billion light-years away. Their light began traveling when the universe was still young. By seeing ancient and nearby galaxies together, scientists can trace cosmic evolution. And what they're finding is unexpected. Large-scale structure may have formed earlier than predicted. Galaxies may have clustered faster. Dark matter may have organized sooner. The universe may have evolved more quickly than our models suggest. And if that's true, our understanding of cosmic history is incomplete. Because this is only 1% of Euclid's mission. 99% remains unseen. Over the coming years, it will continue mapping the sky, filling gaps, sharpening